All right, well, I think we'll get started, everyone. I so appreciate everyone taking time out of their day to participate in the seminar, and I appreciate your patience in 1 second here. I've got my presentation at the end. So I'll start it at the beginning. I left it there from the last presentation I did earlier today. All right. So everyone, my name is Rich Lovedahl. I am one of the senior engineers here at Allen Block Corporation. And again, today's session is geared towards the design professionals. And it is our ABU online series. And today's topic is ASTM 1372. Now, 1372 by itself, it's pretty dry. So what we did is we expanded a little bit, and we're going to talk about the differences between wet cast and dry cast. We're going to talk some production, and a couple spots we'll throw in some best practices and stuff. But we're going to give a thorough vetting of 1372 as well. So hope you enjoy that. And before I get started, I'll just remind you that there are a couple handouts. There is a downloadable link for the best practices guide, as well as the, the spec book. The evaluation form for this session, so you can get your continuing education credits, is also attached. But in the follow-up email that I'll send out, I will also attach all this as well. So, and please feel free to type in questions as you have them in the question bar, and also feel free to respond to that email with questions as well. So with that, we'll get started. So the objectives today is we're going to cover a wet cast versus dry cast concrete. We're going to look at some dry cast, a basic history of where it started. We're going to talk about concrete production, dry cast concrete production, and the advantages of it. We're going to certainly cover the ASTM 1372. Within 1372 is sampling and testing. We'll cover that. Inside of ASTM 1372, they reference C140 and C1262. So the C40 is for testing, and for 1262 is also testing, but specific to freeze-thaw durability. Finishing and appearance is part of 1372, and then we'll finish up with a conversation about best practices. So wet cast. Wet cast means that the concrete has a water cement ratio of around 0.4 or higher. And dry cast is below that, so about 0.3 to 0.6. So just enough water in the mix to hydrate the cement, but it's a zero slump concrete. So when you take the cone off, it doesn't drop like the picture on the on the right hand side, where the wet concrete can slump. Dry cast concrete, it's mixed and poured into a mold that forms the shape. The molds are stripped immediately, and then the concrete cures after the molds, as shown here on the right-hand side. On the wet cast side, we have, obviously, we're going to mix and pour it into molds as well, but the molds have to remain in place while the wet cast material is being cured. So a little bit of history. So dry cast or zero slump concrete dates back to somewhere around the 1870s, and they made one block at a time. And this is a picture of the machine that did that. I just can't imagine the effort it took to make one single block, and then have to have, literally hundreds of them to build a home or a basement or something. So one block at a time. So in the period somewhere around 1900 to 1970, the production equipment around dry cast concrete block really took leaps and bounds forward, part of the Industrial Revolution, and it became, the equipment became bigger and faster, and you could produce a lot more block. And in fact, today, a three-man crew can produce well over 6,000 block in a single 8-hour shift. And that's a lot to do with the introduction of computers and making the machines run very streamlined and efficiently. So I have a video here of a block machine, and this happens to be a Columbia machine. Besser machines are very popular. There's Tiger machines. There's other machines out there, not just Columbia. Just happens to be that I have a nice video from this producer in Oregon. They make a great block, and this, if you can see my cursor, which I hope you can, this right here, that part at the bottom is the mold box. And the mold box has liners inside of it. The liners bolt to the side of the box, and the liners are there to make the shape of the Allen block or whatever block they're making. This is a core bar. This, you're going to see in the video, it'll slide in and it will be left in place as the material is brought over and dropped in, and then the head assembly will come down and vibrate and compact the material into the shape you're seeing. And then the core bar will be pulled out. What will be left is a void down the bottom that we call the notch at the bottom of the block, and that's how that's formed. So let's take a quick look. So the machine slides the core bar in. The plungers are coming down to put the compression and the force into the block. So here's a picture of the block just as they've come out of the machine. They look damp, right? So they have moisture in them. That's what makes the material stay together. But if you were to go up to it right now and take your hands and start to pull it apart, it would pull apart fairly easily. But it now is going to travel down the conveyor, and it's going to be lifted into the drying racks. And once the rack is full, that rack will be taken onto the kiln. And on the other side, you can just sort of see it here in the upper corner. Those blocks are coming back from the kiln that were produced yesterday, and they're going to come down and head to the left to the splitter. Because right now, these two blocks came out of the machine as one unit. There is no separation. But once they're cured, the knife blades of the splitter will come right down in this chamfer here, apply force, and eventually it'll crack the block apart. And those two blocks will be like sister blocks. They could actually be put back together like a puzzle piece, but you can never tell that from wherever they land up in the wall. So let's finish watching the video. So there's the block, the racks that are carrying the block. But here's down in the distance here, that knife blade is going to come down and it's going to break the block. And again, here's the racks, and it's going to swing around and take a look at the computer system here in a second. So I apologize for all the swinging of the camera, but so these are the computers that run the entire system. And again, this block is going to be raised up, and it's going to be put in the top slot. And when that rack is full, that rack will be brought to the kiln. And then you can see the dry block over here that are again on that conveyor that are heading towards the splitter. So very automated. In fact, you don't see any people around here. If they've got the machine dialed in, the machine runs automatically. The feed, the material is fed from the larger hopper, and it's all automated. So it's very, very streamlined, and the automation of the system makes the blocks almost identical to each other in height, length, width, and basically in appearance. You know, they are very uniform. So better production. The mix is consolidated in the form and vibrated under very high pressure. This process provides a very high quality control and a quality assurance to the products themselves because, again, it's consistent. It's using the same molds and so forth. Minimal shrinkage when it's drying. Because the low water content of the block, the blocks dry quickly, and they produce blocks that are very consistent in dimensional tolerances, which is very important. We don't want block to come out of the machine and then start to have temperature cracking and so forth for shearing. during its drying process. Savings and speed. Reusable forms, that is the key here. Those mold boxes can make literally thousands and thousands of block cycles before any of the parts that can wear out need to be replaced. So the reusable forms and the dry casts allow for fast production and production consistency, and the speed of operation saves on labor costs. So again, very, very automated system, which is really great for consistency and magnitude or quantity of block you're making. So the ASTM 1372 is the minimum requirements for dry cast segmental retaining walls. Okay, and I'll say that a couple times during the presentation. It's the minimum, right? It's just a basic set of standards that everybody has to be designed for. ASTM 1372 specification covers dry cast SRW units of concrete, machine made from hydraulic cement, water, and suitable mineral aggregates with or without inclusion of other materials. Sounds like an engineer wrote that, but they want to be very specific about what this is covering. Now, it's modeled after ASTM C90. C90 is for the standard building masonry units. And again, this is taken to the next step for segmental retaining walls. So here's a few nice projects that represent really nice applications. So this upper wall here is a 3-terraced wall. It has a walking path above the second wall and a parking lot above the third. And it's quite a lovely set of walls. And the architect decided to put railings on every wall so that the consistency of appearance is, and again, a lovely project. The one on the lower right is a state park, and it's using the Abbey blend in the Europa collection from Allen Block. And it has a beautiful wall across the way where they cut in this new remodeled roadway. And they have wooden guardrails to really emphasize the beauty of the park and the aesthetics. On the left-hand side is a GRS IBS project. So this superstructure goes across and it literally rests or bears on the reinforced soil mass of which the Allen block is a facing. Now, this is a relatively new concept in SRW design, but it's been around well over 10 years, so maybe not so new. The Federal Highway Department really did a lot of research on this over the last 20 years and have really been pushing it as a great alternative for replacement of the many bridges that we have issues with in North America. The Allen block here is built and compacted every course with grid every layer, and we have a webinar that we did on GRS IBS in combination with no fines concrete, and that's part of these COVID-19 ones that we have done for the last couple of weeks and we'll be doing into the next couple. So please look for those to sign up for some of the remainders if you haven't seen them. And we also have a webinar covering finishing at the top of the wall and fences above, which I think would be very important for you guys to learn too. So testing and sampling of the product. So sample and test units for compressive strength, absorption, and dimensional tolerances, and they're all per the C140. This is the test method for standards sampling of and testing of concrete masonry units and related units. So what we're looking at here for compression is pretty straightforward. We're going to take 5 units, and 3 of them have to exceed 3,000 psi or 20.7 MPa, but all of them have to exceed 2,500 psi and 17.2 MPa. Now, I will tell you that an Allen block producer has no trouble making this minimum. In fact, most of my producers are making block at 4,000 to 5,000 or even higher, depending upon where that block will be used and what requirements they're in. But again, ASTM 1372 is the minimum set of requirements. Minimum absorption requirements. From lightweight units to normal weight units, we're looking at between 18 pounds per cubic foot to 13 pounds per cubic foot. And the testing labs take care of all this. They have C140 all laid out, and they know exactly how to proceed with it. Compression strength, the coupons that are taken, because we're going to take a piece of the block. We would not test the entire block. It would just take too large of a ram or testing ram to break that block. So the ASTM allows for a smaller coupon to be tested. And generally speaking, you're about 2 inches thick, 4 inches tall by 8 inches long, or you have to follow the ratio that they give for height to thickness. Absorption is harvested, the coupon, out of the same unit you're doing the compression coupon. That's important to know, that you have one block and you're getting all the testing coupons directly out of one block. And that absorption coupon should be at least 20% of the full size block. Allen Block provides a template on how to cut our block, and we give this to our producers, of course, and to the testing labs. And there's even an ASTM for actually saw cutting block. So they produce the coupons as needed right there at the labs. And then this is just a AB Classic that's been marked up from where the coupons will be taken. The block's upside down in this picture, and we're going to take the freeze thaw coupons from the wings, the compression coupon from the front face, and across the top, we're going to saw off the top for the absorption coupon. And the absorption tests are calculating 4 different things: absorption and moisture content, density, average net area, and the net volume. Okay, and I am not a testing guy. I do not do testing very often. I have seen it done, but the ASTM C140 will give you more of the equations on how exactly they do this, but they do make it very specific on when a block is to be weighed. And you weigh it when it comes in. You immerse it for 24 hours to make sure it's completely saturated, and you weigh it there. You pull it out of the tank and you dry it off just a little bit, and you take that saturated surface dry weight, and then you oven dry it for a full 24 hours. And you have all these different weights, and you can determine all these 4 different things just by all these different weights. And I want to thank my friends at the National Concrete Masonry Association who provided some of these slides and photos for me to use in my presentation. So I thank you, a big thank you to them. And so here's a couple of those photos. This lab tech is putting the standard masonry unit into the immersion tank. They're going to saturate it over 24 hours. This one, he's putting the block into the oven to dry after having got the weight from just lightly toweling it off out of the saturation tank. And this is a schematic of the immersion tank. So they actually have a scale or apparatus hanging into the water, and they take the saturated block and they put it on the pallet, and they can weigh the block as if it's submerged. And it's a very unique tank and situation. And now this is the compression testing coupon. And you'll notice that the coupon is cut very nicely, but they've also taken the time to put a gypsum bottom and top on it so that the top and bottom are exactly perfectly plumb to each other. And the machine is going to break it. And let's take a look. And again, I'm not sure why my volume is not working. I have it on max, but It did a little pop, but it is not a very exciting video, but I did want to show it to you anyways. And out of this test comes the pounds per square inch of compressive resistance. So let's switch gears and talk a little bit about freeze-thaw durability. ASTM 1372 has it in as a requirement, but it's very particular. It says when required. Okay, when required, sample and test 5 units for freeze-thaw durability in accordance with ASTM C1372. That's the freeze-thaw durability testing standard. But it makes it clear that if the testing is more than 24 months old, that testing or the results of that testing cannot be used for the project that it's using. So we always work with our producers and make sure they know if they need to keep their blocks up to durability standards, they need to make sure they're testing their mix design and their block well in less time period than the 24 months, so we have standard up-to-date testing. 1262 provides specifications for testing in tap water and in saline. Okay, so it's a test method. So it's the accelerated test is in saline. But be very clear, the 1372 test does not require saline solution to be used in the test. It's state DOTs or Ministry of Transportation, those type of entities that may require the harder to pass test in saline, okay? Saline solution. Minimum requirements from 1372 says that the weight loss of each of 5 test specimens shall be less than 1% after 100 freeze-thaw cycles in tap water, or 4 of 5 specimens be less than 1.5% weight loss after 150 cycles. Pass-fail criteria, again, 1262 is simply a test method and does not contain pass-fail criteria. Project specifications will reference ASTM 1262, whether it be tap or saline, and the project specifications will list the necessary pass-fail criteria. Now, here in the state of Minnesota, the state has guidelines for what they suggest on their DOT projects, and that is 90 cycles of freeze-thaw in 3% saline solution. So it's a very tough test to pass. And a shout out to my production facility here in the state of Minnesota, Amcon Block. They make a really terrific block. They have a very high strength, low absorption DOT mix design that they use for passing ASTM 1262. And again, kudos to them to make a great block. So you should know the requirements of your state. The chamber that the testing labs use is very particular. It's a very expensive refrigerator. And what it's doing is it takes our samples where it has water in the basin and it rises very consistently until the water melts, and then it turns around and brings the temperature down. So it's going to freeze and thaw over and over again every day, and to the point where the test is complete. So the testing coupon is often placed in Rubbermaid containers such as this. In this one, you can see those pink straws. That's literally just a straw, like a drink straw, that keeps the coupon from resting on the bottom. And this happens to be an Allen Block test coupon. It's performing very well in saline conditions. And this whole series of coupons did pass the state's requirements. In the ASTM, the 1262, there's a very particular set of guidelines on how to test it. So after a certain number of freeze-thaw cycles, the coupon is taken out of the chamber, it's rinsed off, and then all of the residue that's rinsed off is then collected, and they collect them in these coffee filters, and actually can weigh the material, and that helps them come up with the weight loss. So again, thanks to NCMA for these slides. This particular slide, I don't know whose block it is, but it is a passing test in tap water. We can see that there's one sample that did not perform terribly well, but 4 of them are going along very nicely, and they're less than 1% at 100. But remember, the or part of the pass-fail was that 4 of them have to be less than 1.5% after 150 cycles, and obviously these do. So this is a passing test, and again, this would be very similar to tests going back to any one of my producers that's sending their block in for freeze-thaw durability testing. Pass-fail criteria. Again, saline tests are by far the most difficult test to pass relative to comparing it with tap water. And high compressive strength block combined with low absorption are often a very good block, and it's going to pass. So those two things together aren't necessarily going to say automatically you're going to pass the saline test. It's going to certainly most likely pass the tap water test. But if your blocks are not passing and you've got a high strength block and you've got a low absorption block, you should consider testing the aggregates, because the aggregates themselves could actually split and spall apart during the freeze-thaw cycles. So freeze-thaw, durability, and best practices. So the best practices for SRW design is an Allen Block document. I hope that you've all seen it. And if you haven't seen it, please consider downloading it. I will include it as a link to my follow-up email. It's a really great resource for you. It gives you everything that you want to know about designing walls and constructing walls from A to B. There's many chapters in there covering many topics, and there happens to be one topic particular for today's session about freeze-thaw durability. So in paragraph 1.14, it provides guidelines for freeze-thaw durability when the project specifications do not provide them. So like I said, in Minnesota, we're covered. The state of Minnesota has it, but maybe some projects in a little bit warmer climates may have not a solid set of guidelines. Well, the specifications, or I should say the guidelines and the best practices, give some recommendations. These are just recommendations. They're based on C1372. And the manual provides a temperature zone and exposure criteria map that hopefully is easy to read. It covers in all of the U.S. and Canada. And so it also has the exposure criteria, so negligible or severe or moderate when it comes to exposure to saline or salt, right? Okay, so best practices, we'll touch on that a little bit more later on, but I want to jump into the next category for 1372, and that is the permissible variations in dimensions. So overall dimensions and width, height, and length shall differ by no more than 1/8 of an inch, plus or minus. And this is not including the architectural face, because again, the architectural face is a split face, hard to find an exact spot to measure from. But this is, 1/8 of an inch is a lot. So if you have a block that has is an 1/8 of an inch difference in height from one quarter to the next, the installers might have a hard time putting that block in nice and level. They might have to do some shimming and so forth. So That's kind of a, like I said, minimum requirement. We'd like it to be much tighter than that. So an Allen block unit, because there is a front top lip, we measure the corner right behind the lip. So the lab will measure in 6 different places, and it'll look for those permissible height variations. The length and depth, they're pretty well set by the mold, and you saw the mold in that video. So there's not a lot of variations of the length and depth. And of course, the depth has some variation with the split face, but again, there are hard points that can be measured from. So if you're an Allen block producer, if you've signed a contract with us to make our products, we are going to hold you to a higher level for this particular variations and dimensions. We want the block to be no more than plus or minus a 1/16 of an inch. And again, we're not going to worry about the architectural split face, but with the computers, with the machines, with the the technology we have in producing our blocks, we feel that you can dial in that height a lot better than an 1/8 of an inch. So we asked our producers to make a tighter tolerance block. Finish and appearance. So finish and appearance really had to be put in 1372, just really to cover any incidental things that might come up from an owner of a project to the installer of the project to the manufacturer of the project on what the blocks look like. Okay, all units shall be sound and free of cracks or other defects that interfere with the proper placement of the unit or significantly impair the strength or performance of the construction. That's a mouthful, and I think an engineer must have wrote that. But if your blocks are a 1/4 inch in height difference, that doesn't meet the requirements. So those are a couple of things that you'd want to definitely look for. Minor cracks incidental to the usual method of manufacturing or minor chipping resulting from customary methods of handling and shipping and delivering are not grounds for rejection. And that's important to understand. If everybody's doing what they're supposed to do, you can't just reject a block because there's a little chip in the corner, okay? That's why the ASTM put this finish and appearance part in the specification. Now, I really like this one, and this one almost word for word. That's directly in 1372. The face that is exposed shall not show chips or cracks not otherwise permitted, or other imperfection when viewed from a distance of not less than 20 feet under diffused lighting. So you have to go to your projects at dusk, and you have to stand back 20 feet, and then you can look at it. What we don't want is someone going up with a magnifying glass and looking at every corner to see if there's a little chip in the corner. And again, ASTM had to put something in writing so that there's something to fall back on to mitigate any kind of disputes. And because we don't just make gray block, a statement on the color and the texture had to be put in there. So the color and texture of units shall be specified by the purchaser. The finished surface shall conform to the approved sample consisting of not less than 4 units, representing the range and texture of color permitted. Again, sounds like an engineer. So basically the fit and finish, it has to look good. It has to match with the samples that were picked before the construction and so forth. And then lastly, for the fit and finish is the purchaser or authorized representative shall be accorded proper facilities to inspect the sample units at the place of manufacturing from the lot for delivery. I can't tell you for sure where this came from, but my guess is there may have been a problem on a particular site, and there was a dispute possibly between the owner and they weren't allowed to look at the block in a very nice area. And so they added that to the ASTM. So all my producers have an area where the owner, the purchasing agent, they can come and inspect the product that's going to be used in the wall, prior to wall. So here's another video I want to show you. And this one really goes to how careful our producers handle the block so there are no chips in the block, or very few that happen. Now we are talking concrete. It's the nature of concrete to chip, but you're going to notice an individual walking down here and he's going to very casually roll the block over. So all of these 8 blocks that are coming are all upside down. So the lip is down. You'll notice that the pallet here has the first course of block, and all of these blocks are placed with the notch up, or the right side up. So let's take a look at the video. So you'll see there he's flipping it, and from there the machine paddles push it over, and then another set of paddles push all 8 blocks onto a steel plate, and that steel plate will be lifted up and brought over the top of the first course, and then these side paddles will grab and they'll line everything. When it comes down to rest, it's going to very gently rest so that the lip is down, and again it sets now relatively level at the top of the second course. So the third course will be right side up again, and then the fourth course will be upside down. So very careful to use the machines, and produces a really, really nice block without chipping. So this video shows the shrink wrap machine. So the pallet of block is being wrapped with cellophane, and in this particular case, the new version of the shrink wrap machine actually puts a little strip of advertising on for our producer in Oregon. And what you'll see here is now the machine will bring in another piece of plastic over the top, and the plunger will come down that has a heated pad on it, and it actually melts the plastic just a little bit so that it stays together and really becomes a nice watertight package, where this block and the pallet can be stacked out in the yard until it's loaded on a truck and brought to the site. So compliance. So compliance with the regulations. So if a sample fails to conform to the specified requirements, the manufacturer shall be able to be permitted to remove units from the shipment and then retest them. The new sample shall be selected by the purchaser from the remaining units randomly, and that shipment is tested at the expense of the manufacturer. So I don't know that this really happens a lot because, again, our blocks that are being made are extremely good, okay? And we take great care. So fit and finish and the compliance stuff rarely happens at our facilities. If the second sample meets the specified requirements, the remaining portion of the shipment is considered to meet the specified requirements. But there's a flip side to that. So if the second sample fails to meet the specified requirements, the remaining portion of the shipment is considered to fail the test and the specified requirements. So when that happens, it really goes to another level, and the owner and the contractor and the production people are working out what to do in the future for this block that may or may not already been built. Oftentimes they'll just put a performance spec on it, and they'll check the wall for its performance over the next couple of years, and typically everything's fine. But the ASTM provides some guidance on how to go through this. So here's a few projects I want to show you that have really a tremendous finish and appearance. This is a wonderful project in New Jersey. There's 70 feet of grade change over these large terraced walls. I understand the apartment building on top overlooks across the bay to New York City. So it's a lovely site. Here's a really terrific ashlar patterned wall, and it's using false pilasters. They're integrated right into the wall. A slight modification to the AV Classic unit was used, and again, looks terrific going up into a post above the wall with ornamental railings, and really great fit and finish for this. And there's a great wall to look at too. This is a unique set of stairs. It provides access to the homes up on top of the hill, and you can see that how tight the installer put the blocks. And but I do want to point out that on top, where there's standard step downs, they just simply used the caps, and they did a great job cutting and placing the caps around the curve and so forth. But the architect and the installer really went the extra mile to put these tapered sloping cap units where they came in and saw cut the blocks in a diagonal fashion and then grouted the cap units in place. Kudos to them for really doing a great job on it. It's an Allen block stair, and it's a very nice fit and finish for this project. Then here's a smaller project, but no less important. It's around a handicap accessible ramp. It is the Allen block Europa system with the Abbey blend. It's got lights in it and everything. It's just a lovely picture here in the fall, right, getting ready for winter here. So let's talk best practices one more time. So again, I really encourage you to look at best practices. It's a great book. It covers the durability like we did earlier in the presentation. But what I want you to know is that this is a comprehensive document that was created to support the SRW industry, not just Allen block. Allen block, yes, we were the driving force behind getting it done, but we worked closely with the NCMA. We sat with them and their SRW subcommittee on segmental retaining walls, which is made up of industry professionals. There are other block manufacturers like ourselves. We came together as a unit and created an incredibly good document that everybody should read and get to know if they're going to be part of the SRW design or construction industry part of it. But it also supports the National Concrete Masonry Association's Zero Wall Failure Initiative. Now, this Zero Wall Failure Initiative goes back a few years, but the concept here came out of that SRW subcommittee that all of us manufacturers were going to work together to produce the best blocks possible. And then the National Concrete Masonry Association was going to publish their own version of the best practice so that the engineering community can start designing these walls the absolute best way they possibly can, the best practice way. Now, this is not a specification. It's simply a guide and suggestions on how to design and build walls. But it also means we're going to train contractors, because we don't want any SRW walls failing. We don't want any problems with anyone's walls, not just Allen block walls. Anytime a wall has a problem, an SRW wall, whether it's an Allen block wall or not, it gives a black eye to the entire industry. So we really go the extra mile to work with our producer partners, our competitor blocks, and make sure the best product is put out. And I'll leave you with this, that the products are, well, I've already covered this. I'm going to go to the next slide, excuse me. 1372, again, it provides the minimum, all right? So the producers that embrace best practices, like the Allen Block Producer Network, they use ASTM 1372 as a simple guide, as the minimums. But I'm telling you, they're always exceeding the minimums. They take pride in making an awesome block, a sound block, as good a block as possibly can be made, and shrink wrapped and shipped to the site. We take great pride in that. And our producers are the best. So kudos to all of them. And again, I welcome any questions, and we'll wrap that up. So with that, if you have any questions, I don't see any questions coming right now, but feel free to, again, reply to the email that will be going out later today, possibly tomorrow morning. But fill out the evaluation form, send it in, and we'll get you a continuing education credit as well. And okay, again, I'm seeing no questions, so I appreciate everyone's time, and thank you very much for attending, and look for these other presentations we're continuing to give over the next few weeks while we're all kind of hunkered down during this COVID-19 thing. So I appreciate it, and thank you very much, and have a great rest of the day.